Welcome, my name is Max. I'm one of the developers of ArangoDB. Fortunately, I don't have to waste time to tell you what ArangoDB is because we are selected as one of the 10 projects for the prize. So therefore, you probably know that ArangoDB is a multi-purpose database. That is, it's a document store, a key value store, as well as a graph database. Furthermore, it can be extended by JavaScript code, so we use the V8 engine, within the database server, which gives you a very flexible version of the database. However, I want to tell you what we do with respect to sharding, because earlier this year, we have released a version 2.0, which for the first time contains sharding extensions. So here's the plan. ArangoDB, running on a cluster of machines, consists of multiple DB servers, actually holding the data and internally handling the requests. And each of them is doubled as a synchronous replication pair to be able to provide fault tolerance and automatic failover. However, the requests coming from the outside are handled by so-called coordinators, which are other nodes running ArangoDB, which hold no state, and which just have the task to distribute the requests to the proper DB servers, such that the proper shards can be asked and the requests can be dealt with, probably put together some results, and then return the result. To hold everything together, we use something we call the agency, which is a small database which is fault tolerant in its own, so it consists typically of 3 servers, which holds the metadata for the cluster, and which we also use to organize automatic failover and change of the cluster configuration and synchronize tasks and so on. So that's the big picture. Let me now tell you what we want to achieve with this setup. Eventually, and I should tell you that we have not yet implemented all of this. We have a plan to implement all of this within, say, a year, and but we want to release often and give you versions which work and which do a subset of that. First of all, the sharding extension, the database on a cluster, should essentially provide exactly the same API as a single ArangoDB server, which is a bit of a challenge because the feature set we have is relatively rich. However, on top of this, we want to offer for all these things, in particular for transactions which are already there in the single instance world, we want to have full asset semantics in the cluster. Additionally, we want to have fault tolerance with automatic failover. That is, if one of your machines breaks down, the synchronous replica automatically takes over, and you just get an email to say, eventually fix this machine. The target for our scaling out business is probably up to about 50 to 100 nodes. To go massively parallel would not be realistic with this feature set, so therefore we don't even try to do this. I hope you don't boo me out to say something on a .scale conference. Never mind. Anyway, within this range, we want to be able to elastically resize with essentially zero administration. And well, to see what we do, stay tuned for later releases later this year and enjoy our product.